if you want to send the information now, let us say from one station to the another station, like now if you want to transmit the data which is about 100 kilometers, so on down. So then because it is an 8-bit device, you need to transmit this data, and you need 8 lines. Okay, 8 lines to be established between your transmission station and then your receiver station. So which is very expensive process. Right, so this is what your receiver. So you need to establish 8, 1, 2, 3, 4, 5, 6, 7, and 8. So 8 lines. Now if it is now, let us take 50 kilometers or so, then 8 lines need to be established, which is very expensive. So the first reason is 8051 is a parallel device. And if you want to transmit the data, then it requires 8 lines, which is an expensive task. So which is very expensive. So then what you do here is you convert this data into serial and then you will transmit the data. So that is one solution, right? So by that, by using a single line, you can transmit your data from your transmitter to the receiver. So this is one solution. And then the second disadvantage here is in parallel communication. So this communication can be called parallel communication. So parallel communication disadvantages, now if you try to see, now each transmission line should have the same delay. Each delay, and the same delay. That means if it is 1 bit you are transmitting by using the first line, then the second line and third line, then all the transmission lines should have the same delay. But that is not true in real case. If the delay of any one of the line is different, then the bits which are received at the receiver is different. So this is the second disadvantage in parallel data communication. So the second disadvantage is the delay of communication line. So the delay of communication line is going to come in picture. So to overcome this delay, what we do is to overcome these disadvantages. So this is what your 8051 microcontroller. So this is what your 8051 microcontroller. Now what we do is we should have a mechanism to convert all this parallel data to serial data. So parallel to serial conversion should be there. So which is there on board of 8051. So here we need parallel in serial out shift register. Parallel in serial out shift register. So only one line is enough for transmitting the data, right? And then this is what your receiver, and here you can receive the data, but at the receiver you need to convert this data from serial to parallel. So serial to parallel data converter should be there. This will be your receivers. So here you need serial in parallel out, serial in parallel out shift register. So this facility should be there. So that is there on board. So 8051. So in general, if you want to do the same data transmission by using your 8086, then you will be needing another chips like USART, Universal Synchronous Asynchronous Receiver Transmitter, or UART. So these are the two additional ICs you will be needing for doing this particular task if it is a case of 8086. So if it is a case of 8086. If it is 8051, this is inbuilt. Okay, this facility is inbuilt. So now what we do is, if it is a microcontroller, so microcontroller 8051, So which has a facility of USART or UART on board, UART on board, Universal Asynchronous Receiver Transmitter. So that should be available with this. So what we are going to do in this particular class is how to transmit bits from 8051 microcontroller to the outside world is the first thing. So how to transmit. So how to transmit data from 8051 microcontroller to outside is what one task we need to do. So these are the tasks need to be done. Right? Another one is how to receive data. How to receive data using 8051. Right. So if you get any data, how to receive it is what we need to see. So that is what the objective of today's class. So here what you are going to do is this task you can do using this task you can do by using two resistors. One is called SBUF and SCON. These are the two resistors. This is one resistor which you have to know, and programming point of these things now need to be done. So that is what the agenda of today's class. So now let us take up that particular topic and let us see in the beginning the basic requirements of serial data communication and how do we do and how that facility is available with 8051 is what we try to see. Okay, right. So basics of serial communication. So the computer transfers data in two ways. One is parallel and another one is serial. So in parallel, as we discussed now, often 8 or more lines are used to transfer data to the device and is only few feet away. In serial data transmission, the transfer to device is located at many meters away when the serial method is used. So the data is sent one bit at a time. So in serial transmission, now if we try to see, in serial transmission, okay, in serial transmission, here this is your sender and then this is what your receiver. And in parallel, as we discussed up to now, the sender should have 8 lines and then the receiver should have 8 lines. So at the transmitting end, the byte of the data must be converted into serial bits, and at the receiving end, the serial data has to be converted into a byte. So using a serial in parallel shift register, this can be done by using that. So when the distance is short, the digital signal can be transferred as it is on a simple wire and requires no modulation. But if the data is to be transferred on the telephone line, it must be converted from zeros and ones to the audio tones. This is in audio signal, telephonic conversation. This conversion is performed by a device called modulator and demodulator. If the data is to be transferred on the telephone line, it must be converted from zeros and ones to the audio tone, and this conversion is performed by a device called modem, modulator or demodulator. So the serial data communication uses two methods. So in serial data communication, one is synchronous method, transfer of block of data at a time, and asynchronous method of transfer, a single byte at a time. So mostly widely used method is asynchronous method. Okay, asynchronous method. So it is possible to write software to use either of these methods, but the program can be tedious and long. Right. So there are special ICs. So there are special IC chips made by many manufacturers for serial communication, as we discussed. One is UART, Universal Asynchronous Receiver Transmitter. Another one is USART. So the data transmission can be done in 3 ways. One is off duplex and full duplex. So if the data can be transmitted and received at is a duplex transmission, If the data transmitted one way at a time, it is referred as half duplex. If the data can go both ways at a time, then it is called full duplex. So here now this is a simplex transmission of data. So this is your transmitter and then this is your receiver. So at a time you can transmit your data, then that is simplex mode of thing and data transmission. And in half duplex you have transmitter and receiver, and there is the receiving end, receiver and transmitter. So now let us take if this transmitter is transmitting the data and then this receiver, it is receiving the data. At a time the data transfer can be possible from one to another direction, means one way to the another way. At the same time, the same single line can be used by this transmitter and then this receiver can receive. The data transmission can be of this way. So this at a time the data transfer can take place, either this way or this way. Then that type of transmission is called half duplex. Then full duplex is you have separate line for your transmitter and receiver, and then transmitter and receiver. So at a time the data transfer can be possible in both the ways. Right. So this is called full duplex transmission. So now then the widely used method. So the widely used method for data transfer is asynchronous method. Right. So then you should have the chip of UART. So a protocol is set of rules agreed by both the sender and receiver, and how the data is packed, and how many bits constitutes a character, and when the data begins and ends. So these three information has to be known, and we call it as a protocol. A set of rules agreed by both sender and receiver, and how the data is packed, and how many bits constitutes a character, and when the data begins and ends. So asynchronous serial data communication is widely used for character-oriented transmission. This is important. So asynchronous serial data communication is widely used for character-oriented transmission. So each character is placed in between start and stop bits, and this is called framing. So start bits and then stop bits point of view, so each character is placed in between start and stop bits. So the start bit is always one bit and the stop bit can be one or more bits. So, but we prefer only the stop bit is also 1, right? The stop bit is also 1, which is a high. So the block-oriented data transfer uses synchronous method. So now let us take an example how a character A will be transmitted. So the ASCII character of A is 41. So this is 4 and then this is 1. So how this character is going to be transmitted? Now let us try to see. So then you have a start bit, and then here you have D0, and here you have D1, and so on up to D7. Right. So D0, D1. So this is 1, 0, 0, 0. And 0, 0, 1, 0. So these 7. So then start and then stop it. So then your data, the character, is packed with a start bit and a stop bit. So this is a frame. So the 0 low is referred as space. And the transmission begins with the start bit followed by D0. That is the LSB. Then the rest of the bits is until MSB D7, and finally the one stop bit indicating the end of the character. So this is the stop bit. The stop bit is a generally 5 and space. So the 0 is referred to as space. And when there is no transfer, the signal is high, and which refers to as mark. When there is no signal, and then this is marked as high, which we call it as mark, which we refer as mark. So the data transmission of a character A, which is equivalent of 41, is framed like this, and the frame has a start bit, a stop bit, and indicating there is no data transfer before, then which is indicated by mark. So due to the extended ASCII characters, 8-bit ASCII data is common. And in older system, ASCII characters were 7 bits, but in modern PCs, the use of one stop bit is standard. Because earlier you have a mechanical device kind of thing at the receiving end, which is very slow. So there used to be, include 2 stop bits in earlier case. But now, 1 bit is enough. Right? So now coming to the data transfer rate. Right. So the rate of data transfer in serial data communication is stated in BPS, which is bits per second. Bits per second. But another way we use it as baud rate, the number of bits per second. So it is modem terminology and is defined as number of signal changes per second. So in modem point of view, we try to discuss we define it as the number of signal changes per second. But in modems, there are occasions when a single change of signal transfers several bits of data. So IBM PC XT, right, in 1980s, which supports up to 100 to 9600 BPS. But Pentium-based PCs can send the data up to 56 bits per second, 56,000 bits per second. In asynchronous serial data communication, the baud rate is limited to 100 kilobits per second. 100 kilobits per second. And if you have the computer, and if you want to transmit, you have the microcontroller, and then the microcontroller, having a signal of 0 and 1, which is of logical, if it is a TTL 5 volts and then 0. But the standard was set long before the advent of TTL logic family, and its input-output voltage levels are not TTL compatible. So here, a 1 is represented by -3 to -25 volts, and a 0 bit is represented with +3 to 25 volts, +3 to 25 volts, and -3 to +3 is undefined. So the interfacing standard was RS-232 earlier, which is set by Electronics Industry Association in 1960. And this is what the 25-pin IC, right, which is RS-232, which is of 25 pins. But we are not using all the pins, so it came up with an RS-232. The IBM introduced the DB9 version. So that the DB9 version, here is having, 9 pins. The first one is data carrier rated, receive data, second pin. Third one is transmitted data, data terminal ready, signal ground, data set ready, request to send, clear to send, ring indicator. Okay, so these are the 9 pins which we are using currently. You may see this of connection of your microcontroller board to computer through this particular port. Okay. So coming to the data classification, you have the current terminology is DTE, data terminal equipment. This is like your computer. And another one is DCE, data communication equipment like modems. Okay, like modems. So the simplest connection between PC and microcontroller at least requires 3 pins. One is TXD, another one is RXD, another one is ground. So your microcontroller, if you want to connect it to the computer, then it requires these 3 pins: TXD, RXD, and ground. Then the other pins are DTR, data terminal ready, and DSR ready, data set ready. So when terminal is turned on, it sends out a signal DTR to indicate that it is ready for communication, like computer. And data set ready, when DC is turned on and has gone through the self test, it asserts a DSR to indicate that it is ready to communicate. And RS-232 pins, that is RTS, request to send. When DT device has byte to transmit, it It asserts RTS to signal the modem that it has a byte of data to transmit. And CTS stands for clear to send. So these are the bits we are trying to see of a DB9 RS232. So CTS is clear to send. When the modem has room for storing the data, it is to receive. Right, it is to receive. Then it sends out a signal CTS to DTE to indicate that it can receive the data. So here it is of DTE only, but null modem connection. No modem is used in this case. And DCD data carrier detect. The modem asserts the signal DCD to inform that DTE that a valid carrier has been detected and that contact between it and the other modem is established. This is data carrier detect pin. And another one is ring indicator. An output from the modem and input to a PC indicates that telephone is ringing. So this is a ring indicator. It goes on and off in synchronous with the ringing sound. So then, when you connect this 8051 to the microcontroller computer, it can be done through RS232, but 8051 signals are of 0 and 1s, which has to be converted to a logic which can be equivalent of your RS232 voltage levels. So 8051 has two pins that are used to specifically for transferring and receiving the data serially. These two pins are called TXD and RXD. And part of the port 3 group, P3.0 and P3.1 of 80 microcontroller are these particular TXD and RXD pin. So these pins are TTL compatible, but we are transmitting the data to RS232. So then that should be RS232 compatible. So then we need a IC MAX232 which requires 4 capacitor. This requires 4 capacitor. So 8051 output we connect to MX232 and MX232 output will give it to your RS232 DB9 connector for transmitting. So this MAX232 will convert the TTL logic level to RS232 logic levels, which is of, like as we said here in TTL logic. So here in TTL logic, 0 we will consider it as ground voltage, ground potential, and 1 as 5 volts. But whereas in RS232, minus 3 to minus 25 can be considered as logic 1, and 3 volts to 25 volts can be considered as logic 0. So MAX232 will convert this voltage levels to RS232 voltage levels. But here it requires 4 capacitors, MAX232. So then the Maxim company, they come up with another IC called MAX233. Right, MAX233, which doesn't require any capacitor. So it eliminates the need for the capacitor, this MAX232. So this is what your 8051, then you will be having MAX232, and which will be converting your given voltage levels through DB9, and through DB9 you can connect your pins to the computer, right? So serial communication, coming to the baud rates can be of 110, 150, 300, 600, 1200, 2400, 4800, 9600, then 19200. So the baud rate supported by this is IBM PC BIOS. It's 486. Now, if you take an example, so this example is taken from Masidi book, microcontroller by Masidi. You know, this is 8051. This example is from 8051 microcontroller and embedded systems. Microcontroller and embedded systems by Muhammad Ali Masidi. Ali Masidi. is the author. So now let us take this example. Now let us take the microcontroller is having a crystal frequency 11.0592 megahertz and find the TH1. So this we studied in our timer very clearly. TH1 value needed to have the following baud rates. So I want a baud rate of 9600, 2400, 200. So now you try to see. Now you try to see the machine cycle frequency of 8051 is 11.0592 megahertz. So now when we are connecting it to the UART, that is divided by 12, so then the frequency here to the timer which you are giving is divided by 12, which is of 921.6 kilohertz. 921.6 kilohertz. And this, if it is divided by UART, by now let us take 3 or 12 or 24 or 32. So then if it is divided by 32, then 28,800 is the frequency provided by UART to the timer to set the baud rate. And if it is 3, 9600, which is equivalent of -3, and hex code is FD. So this has to be loaded into TH1. So TH1 is a resistor of timer 1. Okay, timer 1, which is of 8 bit. So if it is the baud rate, if it is 2400, then it is equivalent of -12 of F4. So F4 has to be loaded into TH1. And if it is 24. Right, 24, so then where -24 means E8 is the XR equivalent has to be loaded into TH. Right, so here this is 20,800, right. So then the frequency provided by UART to timer 1 to set the baud rate. So that means we are using 8253 to set the baud rate, but that baud rate has to be loaded into the counter, so the counter TH1. So here you notice that 1/12 of the crystal frequency is divided by 32 is default value upon the action of 8051 reset pin. So we can change this default setting. This is explained at the end. That is what the setting. Right. So this is what the baud rate it is set to the timer is. So if I want a baud rate of 28,800, okay, 28,800, the equivalent code, now this is what is needed to be in your TH1. So if it is 9,600, TH1 should be loaded with the FD, and 2,400, then F4 has to be loaded into TH1, which indicates a baud rate of 2,400. And you need to load the value E8 into TH1 to fix the baud rate of 1200. So in programming, you need to do this. Right? So different baud rates, and 9,600, 4,800, 2,400, 100. So if the crystal frequency is this, so then the TH1, the decimal value or the hexadecimal value now need to be loaded into TH1 register to provide by the timer that particular baud rate. So TF is set to 1 every 12 ticks. So it functions as a frequency divider. So now here, now let us take this piece of code, move SBUF. So SBUF is the register associated with the UART of 8051. So D equivalent is 44. So now copy this into SBUF and then move that into the accumulator. So now let us try to see what is this SBUF register. So SBUF register is an 8-bit register used solely for serial communication. So SBUF register is a 8-bit register. So it is a 8-bit register and it is used for serial communication. So for a byte data to be transferred via TXD line, it must be placed in the SBUF. So if you want to transmit any data by using 8051 microcontroller through the pin TXD, then that data has to be loaded into SBUF register. Okay. So what is SBUF? So now this is what your 8051 microcontroller, and if you want to transmit the data, so then that data has to be placed into SBUF. So SBUF holds the byte of data when it is received by 8051 RxD line. When it is received by RxD line. So when the bits are received serially via RxD, then 8051 deframes it by eliminating the stop and start bits and then placing the byte in SBUF. So when the bits are received serially via RxD pin, then the 8051 deframes it by eliminating the stop and start bits and then it placing the byte in SBUF. So what is this SBUF register? SBUF register is a 8-bit register. Whenever the microcontroller wants to transmit the 8-bit data, it loads this data into 8-bit register SBUF. And when it is receiving the data, so it eliminates the start bit and stop bit, and then 8 bits will be loaded into SBUF. So that is the function of SBUF register. And programming of the serial communication can be done by using serial control register SCON, which is of 8 bits. And the 8 bits are this: SM0, SM1, SM2, REN, TB8, RB8, TI, RI. Now this SM0 is serial port mode specifier. So the serial port mode specifier, so the mode can be decided by using this SM0 and SM1. And SM2 is used for multiprocessor communication. Right. And you make it 0. So this SM0 and SM1, if they are 0, 0, then the mode is serial mode 0. And if it is 0, 1, then serial mode 1 means 8-bit data, 1 stop bit and 1 start bit. It supports. So mostly we will be using this only. So SCON register, we are going to write SM00 and SM11. SM00, SM11. So what do you mean by this? It is a mode 1 operation in which 8-bit data it supports, 1 stop bit and 1 start bit. 1 stop bit, 1 start bit and 1 stop bit. Right. So this is SM0 and SM1. And 10 means serial mode 2 and 11 is serial mode 3. So mostly in 8051, this is what the data transmission we are using. So mostly this has to be done. And this enables multiprocessor capability of 8051. But we are we are not using that. So this bit also we will try to make 0. So now these bits are clear now. This is SCON register, serial control register. And coming to the REN, so this is set cleared by software to enable or disable reception. So you want to enable your data transmission, then you can write an instruction and you can set or reset this particular bit. So set for enabling, okay, set or cleared by the software to enable or disable reception. So then when you are receiving the data, so you want to 8051 want to receive the data or not. So you can enable or disable this particular bit by using a instruction REN. This TB8 and RB8 are not widely used, but this TOI is transmit interrupt flag and RI is receive interrupt flag. So this TI is transmit interrupt flag set by the hardware at the beginning of the stop bit in the mode 1 and must be cleared by the software. So it is set by the hardware at the beginning of the stop bit in the mode 1. And SCON, this RI it is receive interrupt flag. This is set by the hardware halfway through the stop bit at the time in mode 1. Now let us take an example. How do we do programming? So this REN, so when it is high, it allows to receive the data on RxD. If low, the receiver is disabled. When 8051 finishes the data transfer of 8-bit character, so when it is transmitting, then it raises TI flag to indicate that it is ready to transfer another byte. So this TI is transmit interrupt. So when 8051 transmitted 8 bits, it makes the TI bit to raise 1, indicating that it is ready to send the next byte. And TI bit is raised at the beginning of the stop bit. So you have the God bit right in the stop bit, that is. And RI is the receive interrupt. So when 8051 receives the data serially via RxD, it gets rid of the start and stop bits and places the byte in SBUF register. So it receives the data serially via RxD. So then it eliminates the data. So then it raises the RI flag bit to indicate that a byte has been received and should be picked up before it is lost. So when RI is high, it is indicating that a byte is available in SBUF register. So SCON is a bit addressable register. It is, individually you can make the bits, high or low. So now let us try to see how to transmit. So in programming 8051 to transfer a character byte serially, then the first step number 1 what we need to do is the T mode register is loaded with the value 20H, indicating that the use of timer 1 in mode 2. So timer 1, so that means T mode register we have to. So this is the step number 1. So because the baud rate, the frequency now need to be supplied by the timer. So then the T mode register we will load with 20. So that means the 20 is what? 8-bit auto reload to send the baud rate. Right. So the T mode, the timer has to be configured in mode 2. In mode 2, which is 8-bit auto reload to set the baud rate. So then what we need to do, the next one is the TH1 is loaded with one of the values to be set the baud rate for serial data transfer. So this is what we have seen. This is the second step. And the third step is the SCON register is loaded with the value 50H. So this is 50H means what? So it is 50H. 51, no, this is 0, 1, 0, 1, 50H. Right. So now we can understand 0, 1. So 0, 1 is for mode 1. Right. And SM2 and 0, 1. So 0, 1. So this is 1. So receive enable. So receive enable. If it is 1 means what? It allows the data to receive on the RxD pin. Right. And indicating the serial mode 1 where the 8-bit data is framed with start and stop bits. So now so this is step number. So these are the steps need to be converted into program. So this is third step. In fourth step what we do is the TRI is set to 1 to start timer 1. So the TRI is set to 1 to start the timer to provide the baud rate. And the next step is, the TI is cleared by CLR TI instruction. So TI is cleared. So TI is cleared means what? So here TI is 1 means what? It is, it is 1 means what? Transmit interrupt. So it raises TI flag to indicate that it is ready to transfer another byte. So in the beginning what we are doing is we are setting it to 1. Right. So no, we are clearing it, right. So next byte, it's not there. So TI is cleared by CLRI TI instruction. The next step is the character byte to be transferred serially is written into SBUF register. Okay, so then next is the TI flag bit is monitored right, when it is monitored, and by using this instruction, jump not below ti, right, jump not below ti to see if the character has been transferred completely or not. So it is 0 means it is in transmitting. If it is 1 means it is transferred and it is ready to transfer the data. So the next one is to transfer the next byte to go to step number 5. Okay, right. So now let us take this particular example program. Write a program for 8051 to transfer letter A serially at 4800 baud rate continuously. This is what important is. So write a program. So this is what your 8051 microcontroller, and now you send a letter A, right? You send a letter A on TXD pin continuously. Right? So then the first step what we did, TMOD register has to be loaded with 20. 20 means what? Mode 2 configuration. So the mode 2 configuration is this. So move TMOD 20. So timer 1 in mode 2 auto reload. And 4800 is this -6. So move TH1 immediately of -6 or hexadecimal also you can write. So this is a 4800 baud rate. So this is step number 2. Next one is SCON has to be loaded with 50. So which is indicating with the, this is what configuration is. So receive enable is enabled and mode 1 is what selected. So this is what your serial control register. So this is initialization of your timer and serial control register. So now set B TR1 means start timer 1. So this is what the next step. Fourth step is TR1, you are making it to 1. Okay, so you are making it to 1 by using set B TR1. Then you want to transmit which character? A. So that character equivalent is what you try to set. So that would be around 41. So move SBUF 41. And now when it is transmitting, jump not below TI here, right? So the TI bit, if it is not 1, then be here, right? Be here, that means it is moving, right? Whatever the character is here, so TI, so wait for the last bit, right? So you are moving this A into SBUF register, and once it is high means the TI is high means it is ready to transmit the next byte. So clear TI, right? If it is high means next byte ready. So now you clear the TI, then yes, jump again A. So A you are serially transmitting at 4800 baud rate on TX. So when the data is available on SBUF, it will be transmitted on SP. So this is a simple subroutine to transmit a data serially on 4800 baud rate. So now let us take this particular program, write a program to transfer the message S. So here 3 characters is what we need to transmit. S serially with 9600 baud rate with 8-bit data, and 1 stop bit. 8-bit data, 1 stop bit, 9600 baud rate, and the character is S. So then it is the same. So TMOD with loaded with 20 and 9600 baud rate equal and hexadecimal is what you load into TH. And move SCON 50, that means 8-bit, 1 stop bit, and REN enabled. Same thing what we did yesterday in the last program. And set B TR1, start timer 1. Right, start timer 1. So now three characters now need to be transmitted continuously. So first you are transmitting move A, that means the character equivalent of Y, you enter into accumulator, and you are calling a subroutine trans. So in trans, what you are doing, whatever is there in A, you are moving into SBUF. Okay, you are moving into SBUF. And now you are comparing with this TI jump not below. Okay, jump not below. Jump if TI is not below of this particular thing. Right. So then here, that means when it is 0, be here. That means it is transmitting. And when transmission is done, then TI will become 1. So TI will become 1. So then this condition will be violated, then it will come out of the loop. So then again, you know, TI is made 1. So then you make it to 0. Right, you make it to 0 and then return. So first character is 10. Now next character is E. Okay, next character is E. So this can be done by using the same subroutine. Right, and then the next character is done by using the same subroutine. And then do it continuously. So S jump again. So that means load the character Y, E, S. So this is a simple subroutine. When you are transmitting that through SBUF, the content of accumulator, just you check the TI is 1 or not. TI is 1 means transmission is complete. It is ready to transmit the next byte. Okay. So then coming to the importance of the TI flag. So the steps 8051 goes through in transmitting a character is the byte of character to be transmitted is written into SBUF register, then start bit is transferred, 8-bit character is transferred on bit time, and stop bit is transferred, and it is during the transfer of stop bit 8051 raises TI flag. Okay, this TI flag is what it raises, indicating that last character was transmitted and it is ready to transmit the next byte. Okay, it is ready to transmit the next byte. And by monitoring this TI flag, we make sure that we are not overloading SBUF. Another character here is what we are not writing into it. Okay, so if we write another byte into SBUF before TI is raised, the untransmitted portion of the previous byte will be lost. So we are monitoring this particular TI byte in serial data communication. And after SBUF is loaded with a new byte, then TI flag bit must be forced to 0 by clear TI. After SBUF is loaded with a new byte, the TI flag must be forced to be 0 by clear TI in order for the new byte to be transferred. So by checking the TI flag bit, we know that whether R not 8051 is ready to transfer another byte. So this is the importance of TI flag. Now we try for. So now we'll try to see what needs to be done or how we can receive data on 8051 microcontroller. So in programming 8051 to receive the character byte serially, so we load 20H in TMOD register as usual to provide baud rate, and TH1 is loaded to set the baud rate. So then SCON register is loaded with the value 50H, which is which enables the REN1, and TRI is set to 1 to start timer. So this is as usual, these 4 steps. So step number 1, step number 2, step number 3, step number 4. Timer will start the count. And here, this is what receiving. So we use this RI. We'll clear this RI by using CLR RI instruction. Clear RI, and we'll be checking this by using instruction jump not below to see if the entire character has been received yet or not. Okay, so this RI bit is of SCON resistor. So this RI is of this RI flag is of SCON resistor. So we are checking this. For transmitting we will be using TI. So step number 4. So next one is we have to clear RI. So RI is cleared by CLRI instruction, and then we will be checking this RI flag whether all the bits are received or not. So when all the bits are received, then this RI is raised to 1 by using SBUF resistor, means all the bits are received. So that is step number 6. Then we go for the next receiving bit. Clear this, and again we check it, right, and then it is made 1. So then we will clear. Now let us take an example. Write program 8051 to receive bytes data serially and put them in port 1. You are receiving data, and now let us take the received data need to be displayed where your LCD or 7-segment display would be connected. So now that kind of application you can choose. That means here program 8051. So on RxD you are going to receive the data, right? So with a baud rate of 4800. And the data which you are getting, you write into port 1. And for the port 1, your LCD or 7-segment display would have been connected. So received data can be displayed where your display device is connected. So this can be considered it as port 1. So you are from receiver, and then this is what your port 1 where it is connected. So as usual. So the thing is, the timer has to provide the baud rate. So that auto reload mode is timer mode 2 is what need to be selected by sending 20. And 4800, the equivalent hexadecimal thing is loaded into TH1. And SCON is loaded with 50. And set the timer 1. So 4 steps. Step number 1, 2, 3, and 4. And now jump below, not below of RI. So be here. Jump below or not below until it becomes 1, be here. Right. So then once it is a high, so then whatever is there in the SBUF, move into the accumulator. So jump not below RI. Jump below RI means what? When RI is low, right, then come out, but not below. No, when until RI is 1, be here. So RI is 1 means what? It is, all the bits are received. So then when the bits are received, that will be there in SBUF register. That SBUF register you move into accumulator. Okay, you move into accumulator, and the accumulator content now you move into port 1. So move A into P1, and then now you clear RI. So when all the bits are received 1, so then that will be made 1, and SJump here. Right, whatever the data you are getting serially on 8051, right, and then you just take the data. So this is what simple program you can write to receive the data on 8051. Okay, so now similarly we can try this kind of examples. Assume that 8051 serial port is connected to the COM port of IBM PC. And on the PC, we are using terminal.exe program to send and receive data serially. P1 and P2 of 8051 are connected to LEDs and switches respectively. Write an 8051 program to send to PC the message "we are ready." So second one is receive any data sent by PC and put it in LEDs connected to port 1 and get the data and switches to connect to P2 and send it to PC serially. So the program should be performed part A once but part B and C continuously. Use 4800 baud rate, which is very real kind of example which when we are using in our computer. So now this is what you can go ahead. Now we can start with P2 P2 switches are connected. P1 LEDs are connected. Right. So now program is whenever the data key is pressed. So then you have to receive that and send it to PC serially. Okay. Right, so then this is the same, move TMOD 20 and 4800 baud rate. FA has to be loaded into H1 and then move SCON 50 and set BTR1. So move the data pointer at my data and now clear accumulator and get the character. Okay, and then for receiving and so a call send. So send is here you are checking this. What we have now just discussed, right? And increment the data pointer. This is for sending and coming to the receiving, right? So now read the data from port 2 and a call send, right? So then coming to the receive. So here and then when key is pressed. Right, and then coming to the receive, here this is what we now just discussed. It is put in the form of a subroutine. So this is what an example. So this transmitter of 8051 is connected to VC, and RxD is connected to COM port, and port 1 is connected to LED. Switches are connected to P2. And you can send a message, we are ready at my data, which you are pointing out by using your data pointer. So now coming to the importance of RI flag, in receiving bit via its RxD pin, 8051 goes through the following steps. What are the steps? It receives the start bit. That means it is indicating next byte is the first bit of the character. Then 8-bit character is received 1 bit at a time. Then stop bit is received. Right. Then the stop bit is received. When receiving the stop bit, 8051 makes RI 1. Okay. RI 1. So until RI 1, you be there. When it is 1, it will come out. So it indicates that entire character byte has been received and must be picked up before it gets overwritten by an incoming character. So by checking RI flag bit when it is raised, so we need to check this. That's what we did in this our program. So we just check this RI thing until it becomes 1. Okay, be there. Okay, so that is what the importance of this particular RI flag. And the baud rate, there are two ways to increase, you can increase the baud rate of the data transfer. So to use a higher frequency, then system crystal is what fixed. Then you can change that, or to change a bit in the PCON register. The PCON register is an 8-bit register, so it is not a bit addressable register. So when 8051 is powered up, SMOD is 0. Okay, SMOD is 0. So you can set it to high by software and thereby double the baud rate. So this SMOD bit is what you can use. So this is what you can try to do by a simple program, right? By a simple program. So now if you try to see, move, right? Move the PCON A. That means now this is what the setup. This is what your microcontroller crystal frequency, which is divided by 12, which is of 921.6 kilohertz. So when S mod when it is 1, right? So it is of 57,600 hertz. So the timer to set the baud rate. So it is divided by 32 when S mod is 0, then 28,800. Right. So S mod, by making S mod bit of PCON resistor, power control resistor of 8051, you can double the baud rate. Okay. When S mod is 0, this is what the baud rate. And when S mod is 1, the baud rate will be double. So this feature is also available with microcontroller. So how do you double the baud rate? By just simply changing the S mod resistor, PCON resistor S mod bit to 1. Even then you transmit this, you load this in TH1, then the baud rate will be doubled. So now let us take an example. Assuming that the crystal frequency is 11.0592 megahertz, and so now let us analyze this and what this program does. Compute the frequency used by timer 1 to set the baud rate and find the baud rate of this particular data transfer. So PCON resistor is moved into A and set the accumulator 7. That means make this into D7 means what? S mod is what made 1. So load this into PCON resistor, doubling the baud rate. So now 20 is what it is loaded, and then that particular frequency, so which is of 19,200 baud rate. This S mod is 1. So minus 3, so here it is equivalent of 9,600, because baud rate is this, 19,200 will be your baud rate. And now this is as usual. Okay, this is what. So find the TH1 value in both decimal and hex to set the baud rate to each of the following: 9,600, 4,500 if S mod is 1. So when S mod is 1, it will be doubled. So double means now crystal frequency is 11.0592. So timer frequency is 57,600. 57,600 by 9,600, which is of 6. So 6. So TH1 is of FAH. Representation. 12, then minus 12, right? So which is of F4H, right? So this is how you can do, and then this program you can take up. So write a program to send the message, the F is but one country. So to serial port, so then assume this connected to P1, and then you can write simple pointer programs, right? So this is how you can send and transmit data by using 8051 microcontrollers. So today what we have seen, so we have seen, right, so here we have seen, first we have taken up, so the first thing is we have seen the modes of transfer. So the modes of serial data transfer, so serial data transfer, and then second thing is, by using 8051, so we use FBUF resistor and SCON resistor. So how to program is what we have seen. Then the third thing is, how to set the baud rate. So how to send the baud rate, okay, baud rate, and how to send the data. So how to send the data is what we have seen, and how to receive the data is what we have seen. Okay, and in the last we try to see how to double the baud rate. Okay, double the baud rate with suitable example. Okay, so is this what, this is how the serial communication is performed by using microcontrollers. So is that all right? So if you have any question, you can refer, you can ask, then so that we will be going ahead. All right. So if no more questions, right? So so here, you be sure, like, how the serial data transmission takes place in 8051, and how we come across. So now two resistors is what we have seen. One is SBUF and SCON, and another one is PCON resistor, in which we can use the SMOD bit, for doubling the baud rate of your 8051 changes. So if you have any questions, I can take up. And then on this particular topic, serial data communication, the same thing can be used. Okay, the same thing can be used for other microcontroller too. So in the next class, I'll be discussing on PIC microcontroller. So we'll move on to the next topic. So that is PIC microcontroller, and we'll take PIC 16F877, and then its architecture is what we try to see. So that next class and the next class, we will be finishing the 6th unit.